Hi there! This video series is to display my problem-solving and learning abilities. I plan to show that I can quickly solve any programming problem, regardless of whether I already have expertise in a particular language. I hope this helps others in my field to learn not just how to solve one problem, but how to teach themselves a solution to an unfamiliar problem. For now, I am learning Python. I have no professional experience or formal training in the language, and have only been learning it since mid-January. While I'm picking it up fairly quickly, I cannot claim any real expertise. Today, I'm showing my approach to solving the 13th Project Euler problem, talking through my thought process as we go. As always, I will link to both Project Euler and my repository in the description. Let's dive in. Okay, problem 13, large sum. Work out the first 10 digits of the sum of the following 150-digit numbers. So, here's the thing. I believe that Python will let me cheat. Because in Python, there is no actual limit to the size of the integer. It's based on how much memory space you have, and I set myself up with a lot of memory. So I kind of want to go through this the cheat way, where I just literally add up the sum, convert it to a string, and then display the first 10 digits. And if that doesn't work, or if it does, and then if that doesn't work, or doesn't work in the time limit, or even if it does work, then we can explore other avenues. But just as a real quick, so let's see, we have numbers, which is going to be an array. I'm not sure why it did that. I keep hitting a keyboard shortcut that I don't know about. Go away. And let me see here. Can I do this in Visual Studio Code? Ah, I can. Okay, so I'll undo that actually. We'll just do... And this is at least slightly less painful for both of us than my previous attempts at just manual. Now, I'm doing it this way in part because it just makes my life easier, but also because if this does not work out, using the Python no actual integer limit hack, we're gonna need them to be strings anyway. Because that is the only way in a lot of languages to do a calculation like this, with involving these humongous numbers. And I think my brain's just kind of working on the problem in the background, because what I am doing does not occupy very much brain space. I think that the way that we would want to solve this, if we wanted to find the actual entire sum, like using string manipulation and do it manually, we would look at the very, very last digit of every string, add those all together, and use that to find the last digit, and then use it to find the next digit over, and basically calculate our way through using the same basic principles we all learned in elementary school about how to add, right? Where if you're given 1, 2, 3 plus 4, 5, 6, you add the 3 and the 6 to get 9. Maybe bad sample, there's not remainders. And in this case, there definitely would be. But let's say if you added 4, 5, 6 plus 7, 8, 9. 4, 5, 6, 7, 8, 9. So you'd add 6 plus 9, you'd get a 5, carry the 1, etc., etc. And we would have to do something similar to that. But with, like, converting these strings. Done. Okay, now obviously I still need to add a bunch of commas. Let's do this part first. Doopy 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 doo. And I think that we could do that manual elementary addition relatively easily, but I'm just really curious if Python will do this thing that I expect it to do based on the few things that I've learned about Python. Okay, so you can have that extra comma there, but I don't want to. I personally do not like it as well. That's just me. Most people prefer it. There are good reasons to prefer it. I do not. The good reason to prefer it is that then if you're, like, adding to the list, you're not forgetting to add a comma. But in our case, I don't want to use it, so we're not going to. And functionally, it is no difference. It is just a style preference. If there were a difference in functionality, I would have a stronger opinion. I think those trailing commas and stuff are, like, a big major problem in some languages that I'm more familiar with. Namely Java. But I don't actually know that for certain. I'm pretty sure that you can't do the trailing commas in Java, but I'm not 100%. Okay, so here's what we're gonna do, is we're gonna do numbers equals, this is called a list comprehension, if I remember right. I've been taking some execute program lessons. Neat little website. Numbers, so we want to do int num for num in numbers. And if that works the way that I think it will just give us a whole bunch of integers. And what I want to do, actually, is Python gives us a sum that takes in a list. And let's see if that works. It did. It worked in literally, what is that, 1,000th of a second? And it gave us this number. Kind of doesn't feel like that's right, does it? Let's see, how many digits is this? So 5, 10, 5, 15, 20, 25, 30, 35, 40, 45, 50, so it's 52 digits, and we're adding 150 digit numbers, so I suppose that could be legitimate. Just for the sake of curiosity, I kind of want to see if I copy the first, that's more than 10. If I copy the first 10 digits and put it in the little answer box, did we get the correct answer? First 10 digits. Okay. 53, 4, 5, 6, 79, 10. And that is actually correct. So, again, Python kind of lets you cheat. And obviously this approach is not going to work in very many languages. Python has this special thing where integers can take up memory. Like, integers have no limit. You tried to do this in Java, it would just give you the wrong answer. It wouldn't even be able to convert this to an integer. It's way past the integer.max value. I think there is a big integer. Yeah, there's a big integer class in Java that might work. I don't know if it's anywhere close to big enough, frankly. But again, this is Python. Python lets you cheat. So, as I said though, like, the purpose of the exercise is write an algorithm, learn a new algorithm, figure it out, that sort of thing. We didn't really do that. Like, at all. So I'm going to make this called number strings using an abbreviation, of course. And let's think about, so how would we go about implementing that algorithm where we actually go through and we find the number using, again, that elementary school addition, which is actually an algorithm if you think about it. We aren't taught the word algorithm in elementary school, but we are taught algorithms for things like addition. So for now, let's do another list comprehension, and this time we want to do, I believe it is star and num for num in number strings. Okay, it does not like this star num. But if I do that, will it work? Okay. Don't want this back down here. I'm gonna add another print statement right here just to, like, be clear. Algorithm. I like to do a ... personally. That's just a little thing. Okay. So at first, our number string arrays, all these values are 50 digits long. We know that. and I want to iterate through them backwards. So this is actually now an array of arrays of 50 digits in length. So we want to say for I in range, and we actually want to do, and I'm going to hard code these numbers even though that's poor practice, because I do happen to know what they are. Okay, so that'll start index 49, last index in these inside arrays. Because what we need to do is basically go through every digit. And this one I'm not hard coding because it's just better practice not to. It is a little bit difficult to do this one. Not super difficult, but a little bit. Hard coding is slightly easier in that case, but it's still not better practice, and I'm not gonna try to argue that it is. Just easier on me for the typing. Okay. So we're gonna start with a sum, which is an empty string. Or actually, an array. This is going to be an array of strings. And what we're going to do is, at the very end, we're going to print what is it? Just join? Or is it sum.join, maybe? I'm going to do sum.join. And it looks like the default is to add a space, and we don't want to add a space, so let's do empty string there. Okay, so it's complaining because it's like, hey, you opened a for loop, and then your next line of actual code doesn't have indentations, which is indentations very important in Python. And honestly, very important for readability in any language. Ask anyone who's tried to read a JavaScript program that is all on one line. Okay, so for JN range, length, number string arrays. Okay, so I'm going to say in here, inner sum equals 0, just to get us started. And then for j, inner sum plus equals number string r's of j, and we want the string at I, and actually, because these are strings, we need to convert them to integers in order to add them. And then when we are done, we have this inner sum here, and what I want to do is I want to convert that inner sum back to a string. Is there a better way to do this when we're using the variable? I don't know. Python just lets me do it, so I'm doing it. And then we want sum.insert at index 0, always index 0. We could insert it the regular, we could just append and have it be backwards. Let's order it properly right from the get-go. Inner sum okay, so what am I doing here? So what did I just do is I said we want a character at the index of the length minus 1, which is going to be the last index, basically. Let's add the character to our array that is the last character in our inner sum. And then we want a little remainder that says remainder equals inner sum Okay, so remainder equals inner sum, except it can't just equal the inner sum. Okay. So this will return an array. And if we do that, I think it'll give us the array except, or possibly the string except the last thing. So let's just fake this out so that it runs only once. Kind of a wacky way to do things right here, because why would you set up a for loop and then set it so that it breaks on the first run? Well, in this case, we're doing that because we want to test what we've done. So inner sum is inner sum. Let's just do I don't know if that /n will work. Other slash, maybe. What else do we have? Okay, let's see how that goes. List object has no attribute join. Okay, obviously we're gonna have to do something about that, but let's leave that as an exercise for a little bit later. So inner sum 422, remainder 42, sum 2. Okay. I'm gonna go ahead and throw this in an array to see if it prints out the quotation marks. Okay, good. That's me just checking, is it a string? And it is, so we're fine. Okay. we want to remove this little break statement. And for so here's where the things get real tricky. Because for every time we have a remainder, we want to have the last digit of that remainder. Oh, right. Also, instead of doing this, I could just do -1. I forgot about that. So every time we have a remainder, we want to take the last digit of the remainder and add it on to the inherent sum. And then if we have kind of both, so like in this case, we got an inner sum of 42 and a remainder of 42 come through the next time, we want to add the 2 to whatever inner sum that we get, and then the remainder we want to add 4. So let's see. Tackling the easier part first, which is just get the very last part of the remainder, convert it to an integer. So inner sum plus equals actually, let's do this. So basically, let's say if so 0 if remainder length of the remainder equals 0, else remain int of the remainder -1, because as I just remembered. Okay, so I think that will make it so that the second time it goes through, it will like for the second run I equals 48, it will add a 2 to the inner sum right off the bat. Let's see how well this works. And then, of course, our remainder can't just be set. Like that. So if so I could just do if remainder, because it'll be falsy. Ooh, what I can do is write up in here. If the remainder greater than 1, actually. Because if it is only 1, then we've already added the last digit of it. We want remainder equal to set that last. And then we want to string convert int inner sum to the 1th plus int remainder. And even if it is an empty string in here, actually let's do greater than 0 so that we're cutting off that last digit even if it is 0. And then if it's an empty string, empty string is going to come through as 0, I believe. The odds of it being an empty string in this case, very slim. But let's kind of see. So this will print like 50 times. Okay. Invalid literal. Oh, so an empty string will not be converted to an integer. If it is greater than 0. Okay. Let's go back to this. And then if the length of the remainder is equal to 0. There's almost certainly a better way to do this. But just for the sake of making this error go away. There. Okay, so we went through it. Oh, and we missed a little bit, didn't we? Okay, let's scroll up here. Okay, so inner sum 422, remainder 42, so 2, and then we got 427, and 42 plus 4 is 46, so looks like things are working, but you can kind of see here we forgot a step, because this remainder of 55, that needs to be there. But let's at this point tackle that join. So Python join, that article should work. Oh, that's not an article. That's a hacker rank thing. Oh, I see. So I formatted it quite incorrectly. So you gotta pass join in like that. And let's see if we can get this. That should give us the 55373, etc. There we go. And let's remove this inside print. As you've noticed, if you've watched my previous videos, I like to do print statements to kind of make sure my program's working. Okay, so now the algorithmic approach took... Hold on, I'm getting lost in the numbers. First, let's kind of look through. It looks like, yep, we got the exact same answer both ways. Cool. And let's see, the first one took literally no time whatsoever, probably because we've run it a few times. The second one took twice as long as the first time we ran the first one, because it took 2/1000th of a second. So yeah, whether we do it algorithmically or the cheaty way, I'm going to continue to call it the cheating way, it just does not take very long for Python to tackle this problem and give us the correct answer. So I'm going to call it there, and I'll... Oh, right. I like to check to see if they give us documentation, don't I? I think for this one, it doesn't really matter very much. Because obviously we got, and there isn't any PDF here, but we got a very, very efficient solution. We in fact got two different solutions, one of which would work in... The same basic algorithm would work in any language. It might be a little bit harder to write in some languages than others, but it would work. So I think that we did a real good job here, and I'll see you in the next one.